We built Atlas, now we ship it. A working agent on your laptop and a service real users depend on are two very different things. The gap between them is everything we learned in the production module. In this final we wrap Atlas in guardrails, expose it as a streaming API, containerize it, project its cost, and prove it's provider independent with a live swap. By the end you'll have a complete, deployable, defensible portfolio project and the skills of an applied AI engineer. In episode 17 we assembled the build half into a working Atlas. Today we add the production half. We'll put a guardrail layer between users and the agent, expose it through a streaming HTTP API with rate limiting and health checks, package it in a container, project what it costs at scale, and demonstrate that swapping the model provider is a one-line change. Each of these is an episode we already studied, now we wire them onto the real app. Before we build the shell, picture who's on the other side. Real users are not the tidy tester from your demo. They paste private data into the chat box without thinking. A curious few will try to jailbreak the system prompt or make Atlas misbehave. They'll send empty messages, enormous messages, and malformed ones. And on a good day, thousands of them arrive at the same moment. Every layer we add today exists because of one of these realities. Production engineering is, mostly, taking the messy real world seriously. Here's the whole shipped system. A request enters the API, passes through guardrails, reaches the Atlas agent we built last time, and streams back. Around it, observability traces every span and meters cost, while offline the AVL harness gates every deploy in CI. The agent core didn't change, we are building the trustworthy shell that lets you put it in front of strangers. Let's start with that shell's first layer, guardrails. The moment Atlas is public, its input is hostile by default. Users will paste private data, and a few will try to hijack it. So before any message reaches the agent, it passes a deterministic guardrail layer, validate, redact, and screen. Two deterministic defenses, straight from episode 14. The PII patterns mask emails, card numbers, and phone numbers, so sensitive data is scrubbed before it's ever logged or sent upstream, privacy by default. The injection pattern catches the classic hijack phrases like ignore all previous instructions or reveal your system prompt. These are simple regexes, not perfect, but they stop the obvious attacks cheaply, and they run in microseconds with no model call. The input gate runs in order, reject empty or oversized messages, block anything that looks like an injection, and redact PII from whatever's left before handing it to the agent. And notice check output, we redact again on the way out, because even a well-behaved model might echo PII that slipped through. Defense in depth means you don't trust any single layer, you guard both the door in and the door out. Run it and all three paths work for real. A clean question passes through untouched. A message containing an email and a phone number comes out with both redacted to placeholders. And an injection attempt is blocked outright before it ever reaches the model. This is the deterministic, testable shield every public LLM app needs, and because it's pure Python, it's fast and it's covered by ordinary unit tests. Think of safety as concentric layers, not a single wall. The input layer validates and sanitizes. The output layer redacts and screens what comes back. The behavioral layer, the grounded prompt, and the refusal habit we built into Atlas keeps it from inventing answers in the first place. For higher stakes apps you'd add a moderation model and human review on top. No layer is perfect alone, their overlap is what makes the system hard to break. A guarded agent still isn't a product until it's reachable over the network. So we wrap Atlas in a fast API service that streams its answers, exactly as we designed in episode 16. The browser posts a message, and instead of waiting for the whole answer, the server streams it back as server-sent events, one small token event after another, then a done event. The user sees words appear immediately, the same UX we first met in episode 1, now wired all the way through an HTTP endpoint. Total time is unchanged, perceived speed is transformed. 2 endpoints. Health is the tiny liveness probe your orchestrator polls to know the service is alive, boring and essential. Chat does the real work, it rate limits the caller, runs the guardrail gate, and on success returns a streaming response. Notice how the guardrails and rate limiter sit at the very edge before any expensive work happens. You reject bad and abusive requests as early and as cheaply as possible. The stream generator runs the agent, redacts the output one more time, then yields the answer token by token as SSE events, ending with a done marker the client watches for. And see reply FN, it's an injectable scene. In production it's the real Atlas agent from episode 17, in a test it's a stub, so we can exercise the whole API routing, guardrails, streaming with no model call at all. Testable seams everywhere is what keeps a service maintainable. Rate limiting deserves its own moment, because an LLM endpoint is unusually dangerous without it. Every request costs real money, so one abusive client in a loop can run up a frightening bill in minutes. This is a simple sliding window, drop timestamps older than the window, and if a client has already made its quota of requests, return a 429. In production you'd back this with Redis so it works across many server instances, but the logic is exactly this. Protecting your wallet is a first-class production concern with LLMs. Using FastAPI's in-process test client, we exercise the live API with no server to spin up. Health returns its JSO. The chat endpoint streams the answer as real token events, ending with done. And an injection attempt is rejected with a 400 and a clear reason. Every layer, routing, guardrails, streaming works together, verified by a real request. This is a genuinely deployable service. A service that only runs on your laptop isn't shipped. A Docker file makes Atlas reproducible. The same image runs identically on your machine, a teammates, and production. A few production habits are baked in here. We copy and install requirements before the code, so Docker catches that slow layer and rebuilds are fast when only code changes. Secrets, your API key, come from the environment at runtime and are never baked into the image. There's a built-in health check, and we run a couple of worker processes, which suits Atlas because its calls are IO-bound waiting on the model. Build this image once and it runs the same everywhere. Before you go live, a short checklist earned across this course. Keep secrets in environment variables or a secrets manager, never in the image or in Git. Put timeouts and retries on every model call, like the safe call wrapper from episode 1. Remember Atlas is IO-bound, so scale it on concurrency and latency, not CPU. And wire the evaluation gate from episode 13 into your deploy pipeline, so a change that regresses quality is blocked before it ever reaches a user. Shipping is a discipline, not a button. A shipped feature has a bill attached. Before launch, you should be able to answer what does this cost per 1,000 requests and pick your model tier with eyes open. The benchmark from episode 15 does exactly that. Here's Atlas's projected cost, computed from real token counts and the published price book. 1,000 support questions costs about 31 cents on Haiku, 94 cents on Sonnet, or $4.69 on Opus. Now a launch decision becomes concrete. Route the easy bulk of traffic to Haiku, reserve Opus for the genuinely hard questions, and you can state your monthly bill to the business before you ship, not discover it in the invoice. And you don't just accept that bill, you attack it with the levers from episode 15. The cost-aware router sends the easy majority of traffic to Haiku and only escalates the hard questions, which in our own batch came out about 31% cheaper than using Opus for everything, with no drop in quality. Cache the repeated questions so you skip the call entirely. And cap max tokens, because output is the expensive half of every request. Cost isn't fixed, it's something you engineer down deliberately. Cost is half the picture, quality is the other half. The evaluation harness from episode 13 runs in CI on every change, and the deploy is blocked if faithfulness drops or any golden case breaks. In production, the observability from episode 15 tracks cost and tail latency, alerting you when either drifts. Put together, you ship on evidence, you know what Atlas costs, you know how good it is, and you'll know the moment either one slips. That confidence is the whole point of the production module. One promise left to keep, made all the way back in episode 1, Atlas is not married to any vendor. Let's prove it. Every model call in Atlas, in the agent, the judge, everywhere, goes through the single chat scene we built in episode 1. Behind that one function, we can route to Anthropic, to OpenAI, or to an open model. The other 17 episodes of code have no idea which provider is live. That's the payoff of building the adapter on day one instead of sprinkling a vendor's SDK across 100 files. And here's the swap, concretely. The same chat call, with one keyword changed, routes to a completely different provider and returns the same kind of string. To migrate the entire application, you change the default in one place. No rewrite, no risky find and replace across the codebase. You can A/B to providers on your own eval set, fall back to a second vendor during an outage, or chase a better price, all because of one small architectural decision you made in the very first episode. Step all the way back and look at what you can now do. You can take a raw model and engineer a real product around it, structured, reliable prompting, retrieval over private knowledge, agents that act through tools, and the production craft evaluation, safety, observability, cost control, and deployment that turns a clever demo into something people trust. That is the full job of an applied AI engineer, and you've now built every piece of it with your own hands. Where to from here? First, actually ship Atlas, put it on a real host, and point it at documents you care about. If you want to understand what's happening inside the model, our LLMs from scratch track builds a tokenizer, a GPT, and a training loop from nothing. And whatever you do, build in public, your capstone is concrete proof you can do this work, which is worth more than any certificate. Keep building. And that's a wrap on Applied AI Engineer. Across 18 episodes, we went from a single API call to Atlas, a guarded, observable, deployable, provider-independent agentic-RAG assistant built entirely from first principles, every line yours to explain. You didn't just learn the concepts, you built the thing. The field needs people who can turn these models into real, reliable products, and that is exactly what you can now do. Thank you for building with me. Now go ship something real.